Alright, this will be a very important derivative, okay? Derivative of a trigonometric function. So you have learned before. They have first you have sine, you have cosine, you have tangent, you have cosecant, you have secant, you have cotangent. All of the trigonometric function can be differentiated. Alright, so I'm going to show you the most basic form of the first one will be if you differentiate a sine, right? Differentiating a sine function, all right, a sine function, for example, sine x, you are getting cos x. So in pre-university level, we are not going to talk about how to produce differentiate sine to getting a cos x, all right. It involves some special theorem, all right. So number 2, so if you're differentiating a cos x, you are getting negative sine x, right? You are getting negative sine x. This is also a two basics. This is a basics of differentiation of trigonometric functions. After this, you have differentiating tangent. Differentiating tangent, you are getting secant square x. You are getting secant square x. This can be generated by using the first two basic formula. Differentiating sine, you're getting cos. Differentiating cos, you get negative sine. In order to prove this, you need to know some theorem from calculus, alright, which is not in your syllabus. So now, for number 3, okay, I'm going to use these two basic to generate this formula. So let's see how I'm going to do this. Alright, let's see. So I have y equals to tangent x. As everyone know that tangent x can be written as the ratio of sine x to cosine x, right? So as you see, this is a division, right? So we can apply the quotient rule here. So quotient rule, we have u and we have v, which is your cos x. So as usual, either we apply product rule or quotient rule, we just choose as u and v. So differentiating sine, based on this formula, differentiating sine, you are getting cos x. Differentiating cos, the two basic one. Differentiating cos, you are getting negative sine x, dv dx. So then I apply the quotient rule. So quotient rule, as you know that quotient rule, if you have y equals to u over v, your quotient rule will be v u prime minus u v prime divided by v to the power of 2, right? So I'm going to plug in all this information here that I differentiated into this function here. So let's see. So I have dy dx. Dy dx equals to v u prime. So v u prime means that cos x multiplied with cos x, v u prime, right? Followed by negative u v prime, v prime. So v prime is negative sine x divided by v square, which will be cos to the power of 2x, right? So what we're going to do is differentiate this one, differentiate tangent. So what is the outcome here? So based on here, you are getting secant square x, right? How to getting this? So let's prove it. So dy dx, as you differentiate this one, cos, you have cos to the power of 2x, right? So negative, positive, you're getting sine square x over with cos square x. If you observe carefully, you have to have a knowledge from the trigonometric function. Knowledge, this is an identity. As sine square plus cos square, you know that, everyone know that, this will be 1, right? You know that sine square x plus with cos square x will be 1, right? So it means that this whole thing you can rewrite as 1 over cos to the power of 2x, right? 1 over cos, you know, is secant, right? Secant. So square, so secant square x. So that's why you have proven that differentiate tangent is secant square x here. Alright, so let's see how to differentiate. Okay, you have sine, you have cos, you have tangent, then you have secant, you have cosecant, you have cotangent. Okay, let's see what's the formula. Alright, I'm going to introduce you how to differentiate cosecant x here. So as the formula for differentiating cosecant x, okay, differentiate cosecant x, you will have negative cosecant x cotangent x. This will be the outcome. Means that when you differentiate cosecant x, you have negative cosecant x cotangent x. Right? This is the formula. But how to getting this formula? As I said, always use the first two basic to generate the new formula. Instead of if you forget this, if you forget the formula, you don't know what is the formula, you've forgotten. So what is the formula? So you can always reapply this two basic rule and generate the formula. So okay, let's see how I'm going to prove this. So if I have y equals to cosecant x, right? As you understood that, you know that you have a knowledge of cosecant x is the 1 over sine x, right? 1 over sine x is cosecant x. So, alright, in this case, I know this is power of 1, right? So, I'm going to using the chain rule where I bring sine x to the power of negative 1. Power of negative 1 means that sine x everything to the power of negative 1. So I'm going to apply the chain rule because this is a composite function of sine inside a reciprocal function. So I have differentiate this. So there's a power. So I'm bringing the power in front, negative 1. And sine x and the power I go and minus 1. Alright, minus 1. And differentiating the function inside the bracket, your fx, which will be differentiate sine, you're getting cos x. The basic one, differentiating sine, you're getting cos x. Alright, now I'm rearranging all this. I have negative 1, as this is sine to the power of negative 2, right? Sine x to the power of negative 2 cos x. If I rearrange this, I will getting negative cos x, negative cos x, negative cos x, sine x to the power of 2, right? Sine x to the power of 2. But I believe that my formula will be in this form, so I can further simplify this one. Let's see how I simplify this. Okay, I can rewrite this one to be cos x, sine x square. What is sine x square? Is sine x multiply sine x, right? So if I rearrange this, I can rewrite as 1 over sine x, right? 1 over sine x multiplied with cos x over sine x, right? You see carefully, you have fraction, so you have 1 over sine x multiplied with cos x over sine x. And you know that 1 over sine x is cosecant x. Cosecant x. And cos over sine is cotangent x. That is how I getting the formula for differentiating a cosecant x. I have negative cosecant x, cotangent x. Alright? Okay. Of course, there is another two formula, right? You have another two formula, which will be differentiating secant x. So let's look at it. Alright. Let's look at differentiating secant x. So fifth formula, we will be differentiating secant x. So I know the formula that the differentiate secant x, it will produce secant x tangent x, right? The way of memorize will be differentiate secant x, you get secant tangent. But how to getting this formula? So of course we need to know how to get it, right? So as I said, refer to the two basic one. Alright, let's look at secant x. So you have y equals to secant x, as secant x is defined as 1 over cosine x, right? This is the way of proving this is just like the same of proving the differentiating a cosecant. So we should bring up the cos is to become cos x to the power of negative 1, right? So you apply the power rule, the chain rule. So you bring down the negative and you have cos x, right? Cos x, and you negative 2. Why negative 2? Because you minus 1, right? You minus 1, and differentiating the cos x. Differentiating cos x, basic, you will have negative sine x. Negative sine x. So then you will have negative positive sine x, right? Negative positive sine x, and this will be negative 2. So bring down here, you will have cos x to the power of 2. And I can rewrite this one to be sine x to be 1 over cos x, 1 over cos x multiplied with sine x over cos x. Do you agree with it? You see that? Sine 1 over cos x squared is cos x cos x. So 1 over, if you multiply, you will get back cos x, you get cos x squared. So I just separate it. So now I can know that 1 over cos is secant x, right? Very easy, it's secant x. And sine over cos will be tangent x, right? Which have proven that this formula is true. So let's go for the last formula for differentiating cotangent x, alright? Alright, let's look at the last formula for trigonometric function. So the sixth, so if you're differentiating cotangent x, differentiating cotangent x, the formula will be negative cosecant square x. So this will be the last formula. So how to proven this formula? So it's proving this formula is just like proving the formula for tangent. So for example, you have y equals to cotangent x. As you know that cotangent can rewrite as the ratio of cos x to sin x, right? Definition. So as cotangent also 1 over tangent x. Alright, so you can see that this you can apply uv, the quotient rule. So you have u to be cos x and v to be sin x. So of course differentiating cos, you're getting negative sin x. Differentiating v is sin x, you're getting cos x. Okay, apply the quotient rule. You can refer to the derivation of formula number 3. So you have v u prime, right? v u prime. Your u prime negative sin x, right? Negative sin x, negative with v u prime, right? Now u v prime cos x divided by v square sin x to the power of 2, right? Okay, then you have negative sine square x, negative cos square x divided by sine square x. So as you factorize the negative out, you will have sine square x plus with cos square x divided by sine square x. Look at this, very famous. So sine square plus cos square in trigonometry is also you're always getting 1, right? 1, negative 1 over sine square to the power of x, and negative 1 over sine is cosecant x to the power of 2, right? Sine square, so 1 is cosecant square x. So this will be the 6th formula, right? In this video, I already introduced you all the formula that you need while you derive all the function, all the trigonometric function. And this is the 6th basic formula of differentiating the trigonometric functions. Alright, see you in another video for the example of how to differentiate a trigonometric function.